How MOSFETs work, yet again. Okay, so there's a board. Here's where the power comes in. This is the positive rail, this is the negative rail, this is the wire that goes up to the L & Co power supply, and it's set to produce about 12 volts coming out this wire, going to the positive and negative rails of the board here. Okay, and this is a 10-turn precision 50K potentiometer wired as a potentiometer, so the wiper will provide a voltage that's either from 12 volts to 0 volts, and the wiper there goes to this little open spot right here, and then from there it goes to the gate of this MOSFET. So, and that MOSFET is an IRF PG50 MOSFET. Can you see that? Okay, gate drain source from left to right. The gate is connected only to that gap. The gap goes to the potentiometer for a variable voltage, and then across that gap we have the digital multimeter set on the 200 microamp DC scale. So we're going to be looking at the current that it takes to turn that gate on and off, right? And then the output, or rather we got a wire from the positive rail to a light bulb, the light bulb to the drain of the MOSFET, and then the source of the MOSFET down to the negative rail. So the MOSFET is controlling the light bulb, right? The microammeter, 200 microamps. So this decimal point over here is going to be 1/10 of a microamp. All right. All right. So now let's go ahead and apply. Let's turn the pot. And can you see that? I better turn off the overhead light there. Okay. So as you can see, I hope you can see that if I turn the thing on quickly, turn it off quickly, there's 1/10 of a microamp flowing into the MOSFET gate and out of the MOSFET gate to turn that MOSFET on and off as I vary the voltage on the gate, right? So on, 1/10 of a MOSFET in, and then when the gate is on, there's no current flow. Off, 1/10 of a microamp out, 1/10 of a microamp in, 1/10 of a microamp out. Not even that much. Okay, turn on, turn off. Now notice something here. If I just go very gently with the potentiometer, I can control the brightness of that light and make it dim, on just a little bit, on a little bit more, fully on, right? So depending on the voltage at the gate, I can control whether the MOSFET is off, fully on, or somewhere in between, dimming it or brightening it or however. So here I'm varying the voltage of the MOSFET. Okay, well, how much voltage does it take to do that? Well, it just so happens that I have a voltmeter over here too. See here where it says voltage? So now let's go ahead and hook that up. We'll take the positive lead of this voltmeter and we'll hook it to the gate of the MOSFET. Right there. And we'll take the negative lead from the voltmeter and hook it to the negative rail. So now we're going to be looking at the voltage on the gate and the current. Now, I showed you the current only first because it turns out that this voltmeter has a little bit of an impedance. And so this current here, the 3 microamps that you're seeing, 3.5 microamps, is because of the voltmeter. It's not leaking through the MOSFET, it's leaking through the voltmeter. And I can prove that to you by unhooking the voltmeter, and you see that the current goes back to 0. Okay, so I hook the voltmeter in, and alright, so now I'm going to turn the voltage down, and you can see, I hope, that the MOSFET goes off, or that the MOSFET goes off and the light goes off. Now I'm turning the voltage up. Remember, the current that you're seeing is going through the voltmeter. It's not the gate current of the MOSFET. Okay, 3.2 volts, 3.3 volts, 3.4 volts. You see there at 3.5 volts, that light is starting to come on. The MOSFET is conducting at 3.5 volts to the gate. Alright. Turn it on a little bit more. 3.6 volts. The light's growing brighter. 3.7 volts. It's pretty bright. And at 4 volts or so, it's pretty much full on. That MOSFET's not getting any brighter, even if I give it more and 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 more gate voltage, right? Remember, this current is going through the voltmeter. This is not the MOSFET current. So there at the full 12 volts or so of the input voltage, the MOSFET is on. Even with the voltmeter in there, we still only have 11 microamps of current, and all of that is going through the voltmeter, I promise you. And I can show you that by disconnecting the voltmeter. Okay, see, there's no gate current flowing. It's all flowing through the voltmeter, all of that current that you see right there. Alright, now I'll turn the voltage down. And you can see when we start getting into the 4 volt range, the bulb starts to dim a little bit. And then right in there between about 3.8 volts and 3.3 volts, that's the MOSFET's linear operation range, 3.8 to 3.3. In that range of voltage, it acts like a variable resistor, or if you want to think of it another way, as an amplifier. So small signals, small changes in the voltage. Here we're doing changes of tens of millivolts, right? A few tens of millivolts cause a great deal of change in the brightness of the bulb, which means that a small change in the voltage on the gate causes a big change in the resistance of the MOSFET, right? We know that when the MOSFET is fully on, its resistance is about 2 ohms. When it's in the linear operation range, around in here, between 4 and 3 volts, its resistance is variable from essentially infinite to 2 ohms. Okay? Got that? And once again, this current is going through the voltmeter. If I unplug the voltmeter, disconnect it, now you can see that I still have full control of the gate, right? And you can see that at most there's 1/10 of a microamp of current going into that gate. I saw a 2 there. Okay, there was a 2. Okay, so 2/10 of a microamp into and out of the gate is all it needs to turn it on, and then once it's on, there's no current flowing. Once it's off, there's no current flowing. Okay? And then we have a linear operation range of the MOSFET. Right? So now all I have to do to get an oscillation is make the gate voltage depend on the drain source voltage. If the drain source voltage goes up, the gate voltage goes down, and back and forth, and then I can get an oscillation going. And depending on what's regulating that relationship, i.e. the capacitances and the inductances, I get this oscillation happening at a particular frequency. Okay? Got that? Linear operation of a MOSFET. Thank you for watching.